So here suggests that make that we just taught has some weaknesses. Okay, so what do you think is the weakness? If we look back in this sample file, you can see that, well, one weakness is that it needs to use the command exactly as it is on the shell. Okay, so this is a cleanup task. If I want to remove unnecessary files on Unix, but if I go to the Windows environment, this command will not work, because in Windows the command prompt would take the key command name del for delete, for deleting files. So this is depending on the OS, right? The OS for Unix command looks like this, but if it's Windows, you need to do another different things. And even we said, okay, for GNU C++ compiler, we can, if we switch compiler, we can just change this variable to a different compiler name. Well, the real story is not that simple, because the options, the way these options worked, may be dependent on the compiler. Okay, so different compiler may have different options, to different way to write those arguments in the command. So when you change tools, your compiler or just change the OS, this will need to be updated quite a bit. So when you want to port the system from Unix to Windows or vice versa, you have to do a lot of work on your make file. Okay, so how can we do that? Well, Java, one thing Java is good at is cross-platform, because in the old days, one problem with the C, actually, I guess many of us think of Java. If someone asks you what is the advantage of using Java over C++, can you tell them? Like, can you tell what's the benefit of using Java? Why Java? Well, C++ is 002, so you cannot compare Java to C, because C is not 00. But let's say comparing to C++, what's the advantage of using Java? We know Java is not as fast as C++, right? So why? What's the advantage? Well, one of the advantage is Java was originally meant to be a cross-platform environment, because as long as you have a Java virtual machine running on your hardware, it really doesn't matter what, you don't need to recompile your Java program again. So after your Java is compiled to the intermediate, the bytecode, then it can execute. So that was also one of the objectives, was Java code does not matter what hardware you're using. Java code can be sent to your computer or your device over the internet. So it doesn't need, because the difference is Java runs on virtual code, not real machine code, but virtual machine code, while C++ run on real machine code. So when you change a hardware, C and C++ has to be recompiled. Okay, so Java has the advantage, with the disadvantage being slower, because if it does not run on a real hardware, if it only runs on a virtual machine, A virtual machine is just a simulator of a machine on the real machine. So things get slower. So I guess in principle, Java can never be as fast as C, C++, even when the compilation techniques is keep improving. Okay, so Ant is a Java-based tool, so it inherits lots of the advantage from Java. That means it's very cross-platform. So it does not matter which platform you intend to build your system for. Basically, it should work. Okay, so that is. I basically have explained most part of this slide. And of course, Ant is not the only game in town. There's also another tool called Maven with a different philosophy, okay, build tool. We'll talk briefly about Maven, although. So this slide discusses how you can install and set up Ant, okay? If you want to do that, but you also need to set up some environment variables like Ant home and Java home, okay? That may be necessary, okay? So I won't get into the details of these two slides, okay? These are for the installation. Whenever you installed a tool, my principle is not to go right to try to use it. I would, for my real work, okay, I would do some simple command to see if I have done the installation correctly. So one thing almost many developer tool provide is allow you to ask what version you're using. Okay, so this sets is version was 1.8. Okay, was created in 2010. So this was prepared a while back, and the top is the DOS version, and the bottom is the Mac version. So after that, then you can feel safe that, oh, I have installed it. At least it can tell me the version. So now let's suppose you write a very simple program to just try to find out what version of Java is running and what version of the OS is running, and then to print it out. Okay, and this is the corresponding build file if we are using Ant, A-N-T. Okay, it's in Ant. Will look for the project definition from build.xml. So as you can see, they're all XML code, and you would the concept of target is still there. So there would be inherit from the make. So there's one target called init. Okay. First, the project is called my project, and there's this init, and so if someone try to call it, I think it probably has the same default, that if you try to run your Ant without telling them which target you should achieve, then it will automatically try to do the first one. Okay, and this first one has two tasks. One is make directory, this, and then the other one is to make this directory. So obviously this is the initialization. And then there is another compile task which depends on the init. Because why? Because I want, in the end, I want to compile the source code, okay, whatever from this source directory, and the outcome, I want to place it in the directory called build classes. So I must make sure that it exists. So this make dir will create it if it doesn't exist. But if it exists, then it will be fine. It won't try to, it cannot do it again. So it won't hurt if they already exist. So the compile depends on the init. Okay, so and then this compiled target has one operation, not like the previous target has two operations. This one has one operation using the Java C and with these attribute, right? And then the source directory to find the file to compile, and then the destination directory to put the output. And the third target is, we call it package, and it depends on the compile target. This compile target was defined above, and we give it some description, okay, just like we did here, and it has this task. It will specify the destination file of, it will be creating the myjar.jar, okay, and at this place. And sorry, I made a mistake because I guess I was confusing that the default target for make is the first target, but actually the default target of a project, of a end project, is defined here. So for this project, the default is package. So if I run end without telling which target I want, it will look for this target. And as you can see, package is defined here. So it will try to do this one. And if when it tries to do this one, it finds out that .jar does not exist, then it will create it. Or if it's out of date, then it will do it. Okay, and then these targets form some dependency, just like a tree, so that level by level it will just do the one, recompile the one that is necessary. Okay, so that summarized this. What I just said was summarized here. So this is what it looks like when I run it. Okay, when I run it, and okay, it will, well, eventually it wants to do package, but since package depends on compile depends on init, as we shown here. Package depends on compile depends on init, so it tried to do it one by one. Okay, and now after the jar file was executed, then we can run the jar file, okay, using the Java command. Okay, this is to run it. Then it will tell me I'm running Java 1.6 on Mac OS X. Okay, so this was what the program was written to do, okay, to print out the current version of the uh, Java, JVM, and also the current version of the OS. So these, in Java C, it tells us this, in this target, it tells us where the destination directory is, okay? So you can see in my end project, it has this build class, and it just run out of place on the right side. You will see the file created on the right hand side. Each target element has a description attributes. As here, you see there's this description for compile Java code, description generate jar file. So if I run this end command with the option project help, it will tell me, it will give me the targets and its description so that I can do it. Okay, I can. So tell me the default target is package, and the package description is to generate jar file, and so on. And init does not has a description, so it wasn't shown right here. Okay, so it wasn't shown here because it doesn't has a description. So and this line shows that a capability similar to make. You can do the default package, or you can do a select task. For example, if I just select the compile task right here, then it will try to do the compile, and then because compile depends on init, then it will try to do the init. But since the two directory already exists, so init has no real effect. But it will only do the compile. It won't do the creation of the package, because so it won't do the package target. It will only do the compile thing. So this is the basic steps to create some simple AND projects. First, you create a directory for your project. You create a SRC subdirectory to hold all the Java files, and if necessary, you can create multiple levels of subdirectory and refer to them from your build.xml file. And then your next task is to prepare the build.xml file to do the work, okay, which contains targets. And the targets will contain what are the dependent targets, and so what it depends on, so and also what task it has, okay. And tasks include many things. It can also compile, delete, create files, and so on. So this is basically the things we see right here. We have many targets, multiple targets. Targets may depend on each other, and each target has some task provided by the end tool. Okay, but before we take the break, I hope you will now see how ants solve the problem um, of the OS. For example, you are not specifying the actual command to enter to the OS. You're discussing the tool and the attributes. So ant, if ant is implemented on Windows, then it will translate these into the correct syntax for the Windows OS. And, and since ant was also implemented on Unix, then when you run this in a Unix system, it will also use the correct command in, uh, in Unix. So for us, we really don't have to change the syntax according to the OS. And very similarly, we can, if there's a similar compiler, not Java C, but actually if there's some competing Java compiler out there competing with Java C, then maybe all these attributes need not be changed. You can keep the attributes the same, but you can just switch it. So if let's say you're switching from one compiler, from one tool to another tool, well, as long as the tool will use these attributes, then you don't need to change anything. Okay, you just change the name of the tools, then it will automatically create the right command for you. Okay, so that is done for you by the end tool. Okay, so let's take a 3 minutes break.